The intro of this video has been recorded like 10 or 15 times. I mean, I can't keep the count. With each recording, looking for better ways to explain how powerful data is, and I settled on the current trend in computer science, which is AI. If you have come across any AI model, then you will come to realize that without data, there is no intelligence. Most of these AI models are created from enormous amount of data. You can see this from image generation, prediction models, recommendation engine, and translation models, and so on. In fact, without data, computer are useless, because a computer is an electronic device that takes in data as input, processes it using arithmetic and logic units, and produces output known as information. The output of one process could be the input of another. Without further ado, let's get started, and by the time we are done here, we will understand the basic step. This video is divided in part, maybe 3 parts or 2 parts, right? I don't yet know. This first video, we will be talking about literals, and in our next video, we'll be talking about variables and how variables are represented on our computer. I'm on Compiler Explorer again. The reason why I like using Compiler Explorer is just because, you know, it gives me the output which is very easy for me to show, but there'll be certain things that I will need to, you know, use the compiler I installed. Okay, and the compiler we are using here is the GCC, and I think I can close this menu because let me just leave it open. When writing your program, we have 2 kinds of data. We have literal are also known as constant. These are data that are known at the time you write your program or at compile time, and these data don't change throughout your program. Now we have a dynamic data, which are also known as variables. In a dynamic data, each time you run your program, you might have a different result, because based on the user's input, the users might input a different data each time you run your program. That is the 2 type of data we have when writing your program. We have literals, also known as constant, and we have dynamic data, which are your variables. In this video, we will talk about literals. Let's start by the basic literals we have in our C program. Okay, the integer constant does not contain a decimal point or a radix and can be expressed in base 10, base 8, or base 16. In integer constant, we have a constant such as 10, we have a constant such as 458. We can also express an integer constant using a hexadecimal notation. In hexadecimal notation, we can put OX. These are all known as integers constant. Okay, let us see how this constant can be displayed. For us to display this constant, we have to, you know, set this constant in a variable. Remember, this course is not about variable. We'll take a detailed look about a variable in our next video. An integer variable known as a, and in this value we can assign the constant or x12. For us to print this, we go to our console, write the printf function %d\n. %d just simply means we are printing this as a decimal, okay, as in base 10. Let me talk about base. If you are representing something using a base, you usually start from 0 right up to the base -1. If you're representing something in base 8, you start from 0 right up to 7. If you're representing in base 10, that is from 0 right up to 9. Base 16, that is from 0 right up to 15. Base 16 is the weird one because we usually count in base 10. In base 16, numbers reach right up to F. If you reach at 10 in decimal, in base 16, 10 is equals to A, 11 is equals to B, 15 will be equals to F. This is how hexadecimal numbers have been expressed. I want to talk about something known as char bit. Char bit is the minimum addressable memory in your computer, and it has a macro which is being defined under a header file called limits. And let us print it in like a decimal. On our console, it says 8 bits. Char bits could be 4 bits, it could be 16 bits, it could be 13 bits. Some computers might address memory using 16 bits. Some computers might address memory using 13 bits, so this is not a general rule. That minimum, it depends on your platform. And another thing you have to know is the way in which data is being represented on our computer. Okay, it is hardware dependent. The C standard doesn't impose a particular way in which data is being represented. We'll really take a detailed look about this one in our next video. We are going to see how we represent an integer using sign magnitude or using 1's complement or 2 complement. Okay. I want us to also talk again about endiness. Endiness just simply means how your data which is being represented in binary is going to be stored in your memory. So we have something known as big endian. We also have something known as little endian. Your memory is being divided into chunks, each having a memory address. This memory address is usually from a low address right up to a higher address. Let us just assume that this is our computer's memory, and let us say this is memory address is known as A. Then this one should be A plus 1, and this is A plus 2. This is A plus 3. If we want to store this number 1 in binary is 0001 using 4 bits representation. This number is being represented in a binary. To get it back in decimal, we have to say 2 raised to the power 3 plus this leftmost 0 is the most significant bit because it has the highest magnitude. 2 raised to the power 0, this is the least significant bit. If this value is being stored by storing the most significant bit first in our memory, for example 0001, this is known as big endian. In the other case, if this value is being stored as 1, that is the least significant bit, is being stored first, that is 1000. This is known as Little Endian. Or Big Endian means the most significant bit is being stored as the lowest address bit. A is the lowest address. Meanwhile, Little Endian means the least significant bit is being stored at lowest address. Okay, I hope that makes sense. If you want to know the number of bits found in an integer, the bit times the size of an integer is going to give us 32 bits. How do we print in our value? Percentage I means an integer. We can use percentage O, means we are printing it using the octal notation. We can use percentage X, which means we are printing it using the hexadecimal notation. I hope that makes sense. Now we can use capital X or small x. It don't really matter. That means we are putting a capital case. The next kind of literals or constant we can see is the string. A string is just a series of character that has a null termination. For us to declare a string in our variable, it's very easy. We use this data type called char pointer. I know this won't make sense to you right now, right? But follow with me so that I can get the explanation. To represent a string, we write in a double quotation mark. This is a string literal. Put hello world. Usually it ends with a null character. If you put the quotation mark, the compiler knows this is a string and the compiler is going to add a null character for us. Printing our string is very easy. We use percentage S, right? Then we put our string. We check on the console. We have a hello world being printed out. We can do a left alignment and we can do a right alignment by adding an integer value after our percentage. Put 4 here. A left alignment, I've put 4 spaces. Okay, if I put the -4, you can see I have a right alignment. Okay, a floating point is composed of 2 groups of digits, okay, separated by a radix or a decimal point. A float, for example, let me say float f 3.14. This number is being expressed in base 10. As of the C standard C99, you can express a floating point using a hexadecimal notation. Float hex here equals to 1.5 p2. This p2 just simply means in base 2. Another way in which you can express a floating constant is by using scientific notation. This e is the exponent. That means go -2, 1, 2. The decimal point should be here. That is how we represent our floating point using a scientific notation. And now let us see how floating point is being printed on the console. To print our floating point, use our printf function, and we use this specifier percentage %f. We have also the percentage %e, which means scientific notation, and we have the percentage %g. The percentage %g, the compiler will choose to represent it using the scientific notation or using the normal floating point format. Depending on how large or how big the floating point is, it's going to choose the appropriate format in which it's going to represent it on our console. So let us see how our floating point is being represented. So we can see here, this is our floating point is being represented using decimal. We can see it has 6 decimal place. Another thing you can do is you can also modify your floating point format by using point one. That means you want 1 decimal place. In this case, we just need 2 decimal places. So percentage %e has printed our floating point using scientific notation. The percentage %g, depending on how large your number is going to choose from either percentage %e or percentage %f. Okay, we can print our floating point using a hexadecimal number, which is percentage %a. You can specify the weight of your floating point. The weight of our floating point is 6, but in this case it has added 2 space. That means 6 here specifies the weight, 2 specifies the number of decimal points. So character literals are just symbols enclosed in single quotes. To have a character literal, have a char c equals to, put it in a single quote, we have c. To print our character literal on the console is very easy. Again, printf percentage %c and c. You can check on the console, we have the character c being printed. So these are the basics literals that we have seen so far. Again, remember, we are not talking about variable. Like for example, in this case, int a is a variable. Meanwhile, this value on the right side of your equals to sign, this is known as a literal. We also have non-printable characters. These are characters that they can be printed. They do special things on the console. For example, compile the code and then I run it. The vertical tab. The non-printable characters we have is the \v, right, for vertical tab, \b, \f for form feed, what again, and we have seen \a for new line, \a is for sound. Okay, maybe you want your computer to generate sound. Now let us say, for example, we want to print the character double quotes. To print this double quotation, we use again our escape character, right? If you use our escape character, the compiler is going to remove the special meaning of this. Okay, the compiler also adds special meaning. The character b is being displayed on our console, that is x41. Okay. The compiler won't print this as a string. It's going to print this as a hexadecimal constant. Okay, for you to know more about this format, right, you can check the ASCII table. If you check the ASCII table, you will see how you can use octal or hexadecimal to print character. This is the octal number. If we want to print, let us say, the character a using octal, we can use the value is 101. Let us go back in our program, right? Put an escape here and put 101. Compile again our program. run our program. You have B and you have A being printed on the console. More on stuff like this in our next video. We will talk about characters representation, the binary format, floating point, the IEEE 754 floating point, double precision, all those kind of stuff. I just really want you to stick along, and the next video will be very interesting. So that is it with the basics literals we have when writing our program. My name is Mr. CJ. I hope this has been informative to you, and I will see you in the next one.